In the vastness of the cosmos, galaxies stand as monumental structures that shape the universe. These colossal systems, composed of billions of stars, gas, dust, and dark matter, are not just beautiful entities. They are the fundamental building blocks of the universe itself. Imagine each galaxy as a city of stars with its own unique neighborhoods filled with star clusters, nebulae, and stellar nurseries. As we delve deeper into the nature of these cosmic giants, we find that they are not merely collections of stars. They are dynamic ecosystems undergoing constant change, driven by the forces of gravity, radiation, and the fundamental laws of physics. Each galaxy has a life story marked by formation, growth, interaction, and eventual transformation, revealing the intricate dance of cosmic evolution. Galaxies come in various forms, primarily categorized into three main types: spiral, elliptical, and irregular. Spiral galaxies, like our own Milky Way, feature beautiful arms that spiral outward, filled with young, bright stars and vibrant nebulae, where new stars are born. These spiral arms are rich in gas and dust, serving as the cradle for stellar formation. The dense central bulge is often home to older stars, including red giants, which have evolved over billions of years. Elliptical galaxies, on the other hand, present a more rounded appearance and lack the distinct features of spirals. They often contain older stars and exhibit very little gas and dust, suggesting a more tranquil evolutionary history. The absence of younger stars indicates that these galaxies may have completed their star-forming activities long ago. Irregular galaxies defy classification, exhibiting chaotic shapes and an uneven distribution of stars and gas. These galaxies often result from gravitational interactions or collisions with other galaxies, highlighting the dynamic and sometimes violent nature of the universe. Each type of galaxy offers insight into the complex processes that govern galaxy formation and evolution, illustrating the diverse environments in which stars and planets can form. Our own galaxy, the Milky Way, is a stunning example of a spiral galaxy. Spanning approximately 100,000 light-years across, it is estimated to contain between 100 billion and 400 billion stars, along with vast clouds of gas and dust that give rise to new star formation. Our solar system resides in one of the spiral arms, known as the Orion Arm, nestled within a sea of stellar neighborhoods. The Milky Way is not a static entity. It is a dynamic system, constantly rotating and interacting with its environment. Neighboring us is the Andromeda Galaxy, a larger spiral galaxy that is on a collision course with the Milky Way, set to merge with us in about 4.5 billion years. Such interactions between galaxies can trigger waves of star formation and drastically alter their structures, leading to the creation of new stars and potentially new solar systems. As galaxies collide, their gravitational forces can pull stars and gas from one galaxy into another, igniting a flurry of new star births in the process. These galactic mergers serve as natural laboratories for studying the effects of gravity and the dynamics of stellar populations, helping us understand how galaxies evolve over cosmic timescales. The formation of galaxies is a complex process that began shortly after the Big Bang, around 13.8 billion years ago. Initially, small fluctuations in density within the expanding universe led to the gravitational collapse of gas and dark matter, giving rise to the first stars and proto-galaxies. These early stars ignited nuclear fusion, producing heavier elements that would later seed the universe with the building blocks of life. As these stars aged and died, they exploded in supernovae, scattering their enriched materials throughout the cosmos. Over time, these fledgling structures merged and grew, forming the galaxies we observe today. This process of hierarchical merging is crucial to our understanding of cosmic evolution and the distribution of galaxies throughout the universe. It highlights the interconnectedness of cosmic structures and the role that dark matter plays in shaping their formation. Dark matter, which interacts primarily through gravity, forms a scaffold that guides the formation of galaxies, dictating how they cluster and evolve over time. Galaxies are not isolated. They exist within a vast cosmic web, interconnected by filaments of dark matter and gas. This web serves as a scaffolding upon which galaxies can form and interact. These filaments act as highways along which galaxies can travel, merge, and collide. Galaxy clusters, composed of dozens to thousands of galaxies bound together by gravity, are some of the largest structures in the universe. Within these clusters, galaxies can be found in various stages of interaction, from peaceful coexistence to violent collisions. Studying these clusters allows astronomers to probe the nature of dark matter, an elusive substance that makes up about 27% of the universe's total mass. The interactions within galaxy clusters can also shed light on the mysterious force of dark energy, which drives the accelerated expansion of the universe. By observing how galaxies move within clusters, we can glean information about the underlying gravitational forces at play and the distribution of dark matter in the cosmos. The Hubble Space Telescope has revolutionized our understanding of galaxies by capturing breathtaking images of distant galaxies in various stages of formation and evolution. The Hubble Deep Field images revealed thousands of galaxies in a tiny patch of sky, some of which are billions of light years away, allowing us to glimpse the universe as it was in its infancy. These observations have led to significant discoveries about galaxy formation, such as the role of mergers and interactions in shaping their structures. Each galaxy tells a story of its own, revealing the history of cosmic events and the processes that govern the evolution of the universe. With every new image, Hubble invites us to ponder the complexity and beauty of the cosmos, highlighting the rich tapestry of galaxies that populate our universe. Galaxies are essential to understanding the history of the universe. They are the crucibles where stars are born, evolve, and ultimately die, dispersing their elements back into the interstellar medium. This recycling process enriches the gas and dust from which new stars and planets form, contributing to the cosmic cycle of matter. Additionally, galaxies serve as laboratories for studying the fundamental forces of nature, including gravity and dark energy, which govern the universe's expansion. By examining the properties and behaviors of galaxies, scientists can gain insights into the fundamental laws that govern the cosmos and the potential for life beyond our own planet. The study of galaxies allows us to piece together the narrative of cosmic history, revealing how the universe has evolved over billions of years and what it may hold for the future. As we look to the future, upcoming missions like the James Webb Space Telescope promise to expand our understanding of galaxies even further. With its advanced instruments, Webb will be able to observe the first galaxies that formed after the Big Bang, shedding light on their formation and evolution. By studying the light from distant galaxies, we hope to uncover the secrets of cosmic history and deepen our understanding of the forces that shape the universe. Webb's ability to capture infrared light will allow us to see through dust clouds, revealing previously hidden structures and providing insights into the conditions that led to the formation of stars and galaxies. The data collected will provide unprecedented insights into the formation of stars, the evolution of galaxies, and the potential for habitable worlds. Each discovery will bring us closer to understanding the vast complexities of the universe and our own origins. Galaxies are not just vast collections of stars. They are the fundamental building blocks of the universe, holding clues to its origin, evolution, and ultimate fate. As we continue to explore these magnificent structures, we unravel the mysteries of the cosmos and gain insight into our place within this grand tapestry. Each galaxy, with its unique composition and history, invites us to ponder profound questions about existence, the nature of life, and the interconnectedness of all things. The journey through the galaxies has just begun, and the universe still has many secrets waiting to be discovered. With each new observation, we move one step closer to understanding the cosmic puzzle that surrounds us, reminding us that, in the grand scale of the universe, we are all part of something much larger and infinitely more beautiful.